Hi, welcome back. Today, let us look at how Linux keeps normal programs separate from the protected core. When a program runs on Linux, it does not get direct control of the computer. It cannot simply reach into raw memory, rewrite the disk, or talk to hardware whenever it wants. That would make one broken app capable of breaking the whole system. Linux avoids that by splitting the machine into two worlds: user space, where normal programs run, and kernel space, where the protected operating system core runs. User space is the ordinary world. Your shell, editor, browser, database, web server, and background services all live there. They can do useful work, but they run with limited privilege. Kernel space is different. It is the guarded part of the system that manages shared resources: CPU time, memory, files, devices, networking, and permissions. The split is not decoration. It is the protection model. This boundary is enforced with help from the CPU. Normal application code runs in a limited mode, often called user mode. Kernel code runs in a more privileged mode, often called kernel mode. A user space program cannot just flip itself into kernel mode. It has to enter through a controlled path, and when the kernel has finished, control returns back to the program with a result. The most important crossing is the system call. Imagine a program wants to open a file. It calls into the operating system using a defined system call entry point. The CPU switches into kernel mode. The kernel checks the request. Does the file exist? Is the process allowed to open it? What handle should it receive? Then the kernel performs the work, or rejects it, and returns a value. The program asks, the kernel decides. The reason this matters is simple. Software has bugs. Without a boundary, one process could overwrite another process's memory, corrupt the file system, read data it should not read, or crash the machine by touching hardware directly. With user space and kernel space separated, Linux can contain mistakes. A bad process may fail, but the kernel can protect the rest of the system. This is also how Linux shares one physical machine between many programs. The kernel schedules CPU time. It gives each process its own memory view. It controls file access. It talks to devices and the network on behalf of applications. User space gets useful abstractions. Kernel space keeps authority over the resources everyone depends on. So, the mental model is this. User space is where normal programs run with limited privilege. Kernel space is the protected core that manages shared resources. System calls are the controlled way to cross the boundary. And the point of the boundary is not to make Linux complicated. It is to keep one busy machine safe while many programs run at the same time. Thank you for watching. Subscribe to get notified when the next part drops.